Okay guys, here we go. We're doing function notation today, so you want to be in your note packet entitled function notation. And basically this is using y equals mx plus b again, but just in kind of a different form, little different notation for you. So I'll put y equals mx plus b over here. Alright, m is still my slope, and b is still my y-intercept. Alright, so just kind of keep those in mind. Let's look at the problem that they give you. F of x equals 2x minus 5. Alright, here's the new part. This little guy right here. This is pronounced, I've already said it, f of x. And sometimes they'll have a g there, sometimes they'll have an h, sometimes another letter, but it's always the same. You just say g of x or h of x, etc. And basically this is taking the place of your y over here. Okay, so I could write this same function now, since it's in function notation. I could write it as this. Alright, just taking this f of x out and plugging in a y. Okay, so this one is function notation. This one is, I guess you call it linear equation. A linear equation, if you want. You know, we've used that before. So basically, let's take a look at number 1, example 1. They ask us to do two things. All right. First, this one will go right here. It says find f of x. So I'm looking for this when x is -3. Alright, so these problems, plug and chug problems. Alright, plug in what they give you for x and find what they're not giving you. So I'm gonna every place I see an x here, I'm gonna plug in a -3. So I'll just rewrite it down here. F, and there's an x, so I plug in a -3. And 2, oh, there's another x, and I plug in a -3. Alright, so all I did is turn this one into this one by plugging in a -3 wherever I see an x. Alright, now there's basically just some math to do. This side, this is what I'm looking for, f of -3, and this side I just do the math. 2 times -3 is -6. I take away 5 and I get -11, and that's it. I'm done. Right there, that's part 1. Okay, and we'll go on to part 2 here. They want me to find x, okay, but they give me f of x equals 13. Okay, so we can do this one right over here. I'm going to start with the same function over here that I did before, and every place I see an f of x, I'm going to plug in a 13. Alright, that's really all there is to it. So the very first thing is f of x, so I take that out and I plug in the 13. The other side just all stays the same, because that is just an x, not an f of x. And I have -5. And, well, this now turns into something we've done for a long time now. Alright, just solving for x. So I'm going to add 5 to both sides. And let's see, 13 plus 5, that gives me an 18. Bring down my equals. 2x comes straight down. And -5 and plus 5, those go away. And now I have to divide by 2 on both sides. Alright, and let's see, that's x, because those cancel to 1. Bring down that, and I get x equals 9. Okay, so we did two things there. Basically you have to slow down and see what they gave me, plug that in, and solve for the thing that they didn't give me. Alright, f of x. Now if I really wanted to, I could have left an x in here, but really that's what it's saying. When this function is evaluated when x is -3, the answer is -11. Okay, so in other words, y is -11 when x equals -3. That's what that is saying, really. Okay, so you have 2 checkpoints to do basically the same thing. I think they split it up into one is this part and one is that part. Okay, so give those a shot. I'm going to turn this off and put on the answers to that, so when you're done you can check yourself. Okay, so there's the answers to checkpoint 1. Again, you can pause that when you're ready. Okay, and I'm going to go on to example 2. Alright, now in example 2 they asked me to graph this function. Alright, so I'm going to have to turn on my coordinate plane, and for some reason my coordinate plane is turning my background white, so I'm going to turn a little different color onto my pen to make it a little easier to see. So they want me to graph this function. Okay, now as I told you before, keep in mind y equals mx plus b still holds. So if we can turn this guy into looking like that, then we can use our slope and use our y-intercept to graph it. Well, I told you a few minutes ago, this f of x, you can just take that out and put it in y. Everything else is going to just stay the same. Alright, and what we did before is we found our slope. Oh, well, m is my slope. Okay, so m is 5, 6. That means rise over run. I'm going to go up 5 over 6. Alright, and we also used our y-intercept when we graphed. Alright, my y-intercept is still that one, which is right there. So my y-intercept is -3, which means on the graph it's going to be the point 0, -3. Okay, and if you remember a couple days ago when we graphed equations, we said first go to your y-intercept. Okay, so I'm going to go to 0, -3. That would be right there. I'm going to put a dot. Okay, those are one of the points that work in this equation. Alright, and then we said after that, use your slope. Okay, so I start right at the dot that I just put, the y-intercept, and I go up 5 over 6. 2, 3, 4, 5, 6. And I put another dot. Alright, and then I do the same thing. I go up 5. 1, 2, 3, 4, 5. Okay, and I go over 6. 6 right there. Okay, and I put another dot. Alright, and then once I get 3 dots there, now all I do is I connect them with a straight line. Now I don't have a ruler on this thing, so I'm going to try to connect them with the straightest line that I can. I'll make that one a little bigger. There. Alright, and put my arrows at the end, and there I've graphed it. Now, as we said before, all of the points on this line, if I plug the coordinates in to here, it will work. They are a solution. Alrighty, so that's how you graph the function. It's no different than what we did before. We just turn the f of x into a y, use our y-intercept, use our slope, and then off we go. Okay? Alrighty, so that's example 2. We're going to turn that one off. We're going to turn the coordinate plane off, and I'm going to go on to example 3, although you have a checkpoint that I'm going to turn on first. What I'd like you to do for your checkpoint is make sure you can name the slope and the y-intercept. I realize that they already have this graphed for you, but make sure you can do what I did. Alright, find the slope, find the y-intercept, put your pencil on the y-intercept, and then count off the slope and make sure that you're following to the same points that they have. Okay, so let's turn that off. Let's go to example 3. Write a function g given that g of 0 is 10 and g of 4 is -2. Okay, so we want to now come up with, let me catch up here, we got to go up there. Alright, turn that off. Okay, so we got to catch up with this. We now have to make an equation that looks like that. Okay, and here's the thing. When they tell me this, g of 0 equals 10, they're giving me an x and a y right there. Okay, so they're giving me a coordinate 0, 10 that works in whatever equation I come up with. Whatever equation I'm going to come up with, I plug in 0, 10 and it's going to work. Well, they also gave me a second one. Here's an x and here's a y. So I also know that 4, -2 works. Alright? Well, now it turns into a problem that we did a day or two ago. Alright, I have 2 points that work in some magic equation that I'm going to come up with. Well, I need to find my slope and I need to find my y-intercept. Alright, so we have to go back to our equation for slope. We said it's rise over run, or a more mathematical way, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so I'm going to label my points and I'm just going to plug them in. So I'm going to call this x sub 1, y sub 1. This is going to be x sub 2 and y sub 2. Alrighty, so I just plug them in. -2 minus 10 over, would this be 4 minus 0, this one right here. And I just do the math. -10 minus 2, or -2 minus 10 is -12, and 4 minus 0 is 4. Now this is going to turn out really nice when I divide it, so I'm going to turn it into -3. So there's my slope. My y-intercept. Now wherever my y-intercept occurs, x is 0. So really, I have my y-intercept right there. Alright, that's equal to 10. So I put these two facts together. Okay, I have one here and one here. Alright, and then I just plug them into this. We've done this before. Y equals m is -3, x plus 10. Alright, and that's oh, they want it in function notation. So how do you turn it into function notation? Well, you just take this y and you change it to an f of x. Everything else is the same. Alright, so that is what we're after right there. Okay, and really that's all there is to it for that one. I'm going to go right on to example 4 so we can finish up here. And example 4 is more of a word problem. Alright, you ride your bike at a speed of 12 miles per hour. Use function notation to write an equation. Basically what we did last time, we're going to write an equation in example 3. And they want to know, this is important, giving distance traveled as a function of time. Alright, you guys are going to run into problems that say this kind of thing right here in the future. Here's what I want you to do. When they say, I'm going to underline this a few times, when a function of time, whatever they tell you a function of something, this guy is your x value. The other guy, whoops, not that one, that one is your y value. Okay, so I'm going to make myself a little chart. I'm going to go over here and I'm going to put time here. That is my x, and I'm going to put distance. That is my y. Alright, I'm going to make a little chart and plug in some values. I'm going to look at this. I'm going 12 miles per hour. So if I travel 0 time, well, if I travel 0 time, I've gone 0 distance. Okay, if I go 1 hour, well, if I go 12 miles per hour for 1 hour, that's going to be 12 miles. Okay, if I go 2 hours, again 12 miles per hour times 2, that's 24. Okay, let's do a little more challenging one here. If I plug in a 5 times 12, that's 60. Maybe if I go 10 hours, that's going to be 10 times 12, that's 120. Alright, what this has done for me, it's given me some points. This is the point 0, 0. This is the point 1, comma 12. This is the point 2, comma 24. Okay, I want these all like this so that I can do what I did back in example 3. Okay, this really is a 4. 4. Okay, take that out of there. Ooh, way too big. Okay, 24. Alright, so in order to come up with a function, I need to come up with y equals mx plus b. I have to do the same thing I did in example 3. I got to find my slope, I got to find my y-intercept. So, one's real easy. Right there. That's the y-intercept. 0, 0. Okay? The harder one is the slope. But I do the same thing. y2, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to use these points right here. It doesn't matter which 2 points you use, but I'm going to use that are kind of, I see they're far apart. There's 5 between the 5 and the 10. So I'm going to use these right here. Okay? So these are my 2 y values. Okay? So I'm going to take 120 minus 20. And these are my 2 x values right here. So I'm going to take 10 minus 5. Alright, and 120 minus 20 is 100. 10 minus 5 is 5. And nice. Comes out to be 20. Alright. Yeah, totally did that wrong. Isn't this 60? Yeah. There you go. Make that a 60. Take that out of there. That should be a 60 over 5. Okay. So 60 divided by 5, that's better. That's a 12. Okay, so there's my slope. So that means I plug it into y equals mx plus b. Y equals m, I just figured out, was 12. And b is right over here. That's a 0. If you want to put plus 0 on there, that's fine. You don't have to. But we want it in function notation. So all I do is take this y and I turn it into f of x equals 12x. There it is. Right there. Okay? Now what this does for me is it allows me to use this. Okay, I can use this. F of x equals 12x, and I can figure out how long will it take me to travel 30 miles. Well, to go back up here, 30 miles is my y. So when I plug it into here, I don't plug it in for x because that's my time. I plug it in for y, which we've said before, f of x is another way of saying y. So I'm going to put in a 30 in for the f of x. And all I have to do now is solve for x. Alright, now if I do that math, it actually comes out to 2.5. So how long will it take? It's going to take 2.5 hours. Alrighty, and that is how long it'll take you to go 30 miles. Alright, so that is example 4. If you need to go back and check things out again, that's a lot of information in this section here. So you might have to watch this one again. Hopefully this helped, and we'll see you tomorrow.